All right, in this video, we're gonna learn how we multiply like radicals, and also how we divide like radicals. Let's start with the multiplication property. So the multiplication property of radicals said, like, if you have like x root of a times x root of b would be equal to x root of a times b, right? There is like something like similar, like exponent when we have like for example, when we have like a a b to the x is a to the x times b to the x. There is kind of connection between both properties, but we're gonna get back to this one later. So let's start on the square root or the third root or x root of a times x root of b. I don't want to mix the multiplication with with x, so let's do this as multiplication right here, right? That's multiplication dot, right, times so x root of a times x root of b will be the x root of ab. Let's get some examples here. That looks like all right, let's get some examples. Let's suppose I have like the square root of 2, right, times square root of 5, right? Well, since we have the same, those like radicals, because the same root, right? We have 2 here, as you can see, we have 2 here and we have 2 here. It's the same one, so we can combine them. We can use a property will be equal to the square root of 2 times 5 of 2 times 5 of 2 times 5, which is the square root of 10, right? And let's simplify this radical here. Let's suppose I have like I want to simplify the square root of 90. I want to simplify the square root of 90, right? So the first thing, we have to look for a perfect square. That's one way to eliminate the radical, the root, right? And we know that 90 can be like 3 times 30, right? 3 times 30. And we know that also 90, it's like 45 times 2, right? And we know also 90 is like 9 times 10, right? Now, which factor I'm gonna pick? Because all of them, all three of them, when you multiply, like, both numbers, you will get 90, right? But which one we're gonna pick? Is like 3 times 30 or 45 times 2 or 9 times 10? I will pick this one because this factor here is, right, as you can see, we have 9 as a perfect square, right? 9 as a perfect square. So that would be like, by using the property of multiplication, that's going to be like the square root of 9, right? Let me do it again here. That's going to be like the square root of 9 times 10, right? And by using the property of multiplication, so it's going to be like the square root of 9 times square root of 10. And the square root of 9 says 9 is a perfect square, so it's going to be like 3 times square root of 10. And that's going to be the final answer. Now, what we did here, we just simplify square root of 90 to 3 square root of 10, right? Let's take another example. What if we want to simplify, right? We want to simplify the square root of 27, square root of 27, right? So we know that 27 is 9 times 3 is 9. So 27 is 9 times 3. And by using the multiplication property, right, of radicals, it's going to be like square root of 9 times square root of 3. And the answer will be 3 square root of 3. All right, let's move to division property of radicals. When we have x root of a over b will be equal to x root of a over x root of b. Let's get some examples here. What if we have like the square root, right? The square root of 4 over 9. So that's going to be like the square root of 4 over square root of 9. Square root of 4 is 2, and square root of 9 is 3, and that's the answer, right? Well, remember, if you don't have anything here, we have on the root here, on the nth root or x root, means we have 2. If this one is empty, means we have 2, right? This is the same thing here. But we don't have by default, we just keep it empty. That indicates that we have a square root. Sometimes we may have third root or fourth root. Let's get this example here. Let's suppose I have this example. I have a third root. I have third root of 16 over 27. Well, how we do this? Well, by using the division property, that would be the third root of 16 over third root of 27. Now, in order to eliminate the root, the radical here, and since we have 3, we need to find a perfect cube here, right? We need to make this one as something cube in order to eliminate the root, right? Like what we did in the previous example, when we have a square root of 4 is 2, because the square root of 4, right, is a square root of 2 squared. And remember, since I have 2 here, right, and I have 2 here, that's why we eliminated the radical here, and the answer became like 2. That's why we have 2 there, right? So we got to do the same thing here. We know that 16, well, actually, we don't have a perfect square, perfect cube of 16, but we can just like reduce it. We can simplify it more. So we know that 16 is 2 times 8, right? And since 8 is a perfect cube, because 8 is 2 to the third power, right? So that's going to help us here, right? So let's start with the numerator here. So it's going to be the third root of 2 times 16. Times 8, sorry. That's 2 times 8, right? Over, and 27, I think 27 is quite clear, because we know that 27 is 9 times 3. And we know that 9 is 3 times 3, and here we have 3. So 27 will be equal to 3 cubed, right? So that's going to solve the problem, because 27 is a perfect cube here, right? So the third root of 27, it's going to be 3 to the third power here, right? 3 cubed, right? So let's continue here. So we have by using the multiplication property here, right? So we're going to have the third root of 2 times the third root of 8 over, right? Now, as you can see here, since we have 3 and 3, so we're just going to eliminate the radical here. So the answer will be just 3 in the bottom, in the denominator here. So 3. All right? And let's continue here. So let me erase this. I don't need this now. We just need more space here. Let me just erase this. All right, so we're going to continue here. So we have the third root of 2. Now we know that 8 is 2 to the third, right? So in order to find the cubic root of 8, we want to know what cube of any number, right, will give me 8, right? That's going to be 2, because we know that that 8 is 2 to the third power, and that's good enough to eliminate the radical there. So it's going to be like 3 here, and finally we're going to have, all right, so finally we're going to have this one here. We're going to have third root of 2 times 2 over 3. As you can see, since we have 3 and 3 are the same, so we're going to eliminate 2, and we're going to come up with 2. So the answer is going to be 2 times third root of 2 over 3, and that's going to be and that's going to be the final answer. So as you can see, even with division property, we use multiplication property. It's all connected. All right. On the next video, I will show you like more examples and this and how we connect the square root to or n's root in general, right, or x root to exponent.